Welcome to today's IEEE Geoscience and Remote Sensing Society webinar. We're so glad you're joining us. United by the mission to advance geoscience and remote sensing, GRSS is dedicated to knowledge sharing by ensuring transparent, accessible, and collaborative learning for all. And our webinars are just one way we bring that commitment to life. Designed for students, early career researchers, professionals, and enthusiasts, these webinars address foundational topics as well as a wide range of emerging subjects, while also offering sessions on academic writing, publishing, and career planning. Our webinars are made possible through the collaborative efforts of GRSS's technical committees and various other initiatives, bringing together a diverse community of experts to deliver high-quality learning content. During the webinar, please submit your questions through the Q&A feature, and they'll be addressed at the end. You'll be asked to complete a survey afterwards, which helps us tailor content to your interests. Be sure to check out the IEEE GRSS YouTube channel for previous webinar recordings in case you missed any. And for updates on future webinars, visit the GRSS calendar and follow us on social media. We're excited to have you with us. Let's dive in.
That's great. I think it was a nice video. Hello, everybody across the globe from wherever you are signing in. This is Dr. Adnan Siddiq, Chair of the REACT Technical Committee, and I welcome you to this webinar, which is actually co-organized by two technical committees. As you saw in the video, this webinar series is actually organized by some of the technical committees that are working under GRSS. One of them is REACT, and the other for today is MERS, which is Methods for in Remote Sensing, and the REACT committee is more like remote sensing for environment analysis and climate technologies. So welcome everyone, and without further ado, I would like to actually introduce the speaker for today, Dr. Adam Watts. So Dr. Adam is actually a biologist with the U.S. Fire Service Department, and today's topic that he's going to discuss in detail is around wildland fire management, and he has a lot of interesting results to show. If I'm correct, they're mostly going to be around the case study FASMEE, which has been a long experiment on the fire and smoke modeling evaluation experiment. And Adam is also a team lead for fire and environmental research applications, FERA, at the Pacific Wildland Fire Sciences Lab at the Pacific Research Station. I can say a lot about him. He has done fantastic scientific work. He's also a voluntary firefighter. But in the interest of time, I would like to immediately hand over the mic to Adam so he can share his fantastic work with all of us. Welcome, Adam.
Thank you so much. I really appreciate your invitation. Good evening, good afternoon, or if you're with me in North America, good morning, everyone who's out there. This is an honor to be invited to present on some of the work that I've been involved in and to realize that there is an interest in it. I would like to mention from the outset that as you may follow news of the United States government, those of us who are employed by the U.S. government are under a shutdown, and we're furloughed. So I'd just like to note that as opposed to an official U.S. Forest Service activity, I am presenting this webinar and this content as a scientist and not an employee of the U.S. government. I do this in solidarity with the broader global scientific community. And I also want to say that in times like this, when it can be a bit difficult or frustrating, I really appreciate that solidarity of the global network of scientists to whom we all belong. So thank you once again very much for the invitation to present on this work that I've been involved in. Let me make sure. Have I? Oh, I should share my slides. And before I get too far into my introductions, I just like to make sure that I'm all set up technically. So please give me just a moment because I'm not a great multitasker. Okay, Adnan or Sarah, how do I look?
It looks perfect. We are able to see your slides.
Okay, thank you very much. So here we go. So lots of words. The case study that I'd like to present today is perhaps one of the larger, maybe the largest contemporary active fire research project, active wildland fire, FASMEE, the Fire and Smoke Modeling Evaluation Experiment. I'll do that in just a moment. Let me tell you about the content that I have planned to discuss today. Hopefully we can get through these few topics here. I'd like to go back through some of the original motivations for the project. I'd like to take you through a very brief history of this more than decade-long effort, share with you some of the recent developments. As tough as it is to make predictions, I'd like to just touch on what might be some of the future of this project. And with the very real likelihood in mind that this may benefit future efforts, I'd like to really focus on some of the lessons learned through the last 10 or 12 years of the undertaking of this project. Uh, First, I would like to continue the acknowledgments. Thank you all for spending your next hour with me. And also, I'd like to acknowledge very much the kindness and the invitation of Tianlin Wang from NASA JPL. It was he who connected me to you, and so perhaps we should save it till the end. But if you find this interesting, I hope that you'll thank him as well for making this connection. This is a photo of me almost 20 years ago attempting to or about to launch what we then called UAVs from an airboat in the Florida Everglades. So I've been involved in the pursuit of collecting environmental data sets from these incredibly flexible mobile platforms for about 2 decades. And really what I learned in the course of coordinating this older project was as much as I might be fascinated by many of the different scientific and technical aspects, it's really in the coordinating and choreographying of interdisciplinary teams of scientists and engineers that I find so much joy because of the things that we can all do when we pitch in together and when we translate across our different disciplines. So this is fascinating work to me. Okay, now back to the background of the study. The premise that this study and many like it have been founded upon is that fire and smoke models are critical to the wildland fire system. Here I provide just sort of a personal definition. This is not the official definition of the wildland fire system, but you think about it as this greater community of researchers and practitioners and everyone around us who enable us to produce more understanding and to manage effectively, hopefully, the challenges that we face with fire and smoke. So I will not, hopefully I will not read through all of these different bullet points that I've placed as text on the screen. You can digest that at your leisure. But there have been a number of studies pointing out the importance of premises like this. There have been continuous developments and additions to the library, the constellation really of modeling systems that we use that populate the scientific and management communities. And it doesn't matter whether these are new off the shelf or still in development or widely used and well worn, all of these models thrive on the input of quality data in order to train, evaluate, and improve them. And so the important aspect of these field studies is ideally to provide the modeling inputs that enable us to evaluate and continuously improve these modeling systems, particularly in a world in which we now live, where climate is changing and where some of the scenarios that we see go outside of our boundaries that we initially established and beyond which we're rarely able to extrapolate. So I'll just focus now on one of these post RX Cadre workshops. RX Cadre was one of the predecessor studies. There was Frostfire. There have been several of these multi-organization campaigns to collect large data sets concerning wildland fire. So the realization came that if you have increasingly large and complex modeling systems, you need increasingly large and complex data sets for ground truthing, for all the purposes that I mentioned, evaluation. Model improvement is a general term that I might use for those activities. And it's important for the scientific communities, especially for the management agencies on which these in which these decisions are made, and the models on whom they depend, to have these data sets available and to make this investment in large and coordinated campaigns to collect them. And one of the findings that is especially critical, I'll mention this again, is to govern them from start to finish with a focus on outputs and data. Also, I mentioned a few times integrated campaigns, so I'd like to touch just a moment on what I mean and what we in the FASMEE project leadership refer to as integrated. It all starts with the premise and the realization that so much of our understanding of fire and smoke, I should say wildland fire, is produced with integrated knowledge itself. For example, from the fire side of things, the combustion and consumption, what you might call fire effects, are affected by several different factors, including fuel loading, fuel size, arrangement, continuity, fuel moisture. The list goes on and on. If you are thinking about smoke and emissions, obviously we know that there are many factors that lead us to an understanding of smoke production and effects. This instance comes from the National Wildland Fire Coordinating Group, NWCG course RX 410, Smoke Management Techniques. We introduce trainees in that course series to the concept that in order to understand smoke production, you have to know something about burned area, fuel loading, consumption, emission factors in productions, dispersion, concentrations. The list goes on, but the applications are extremely important. I'll provide just this one example from North America, particularly from the United States, where the U.S. Forest Service, EPA, co-produce the Air Now or Blue Sky systems. The Air Now is the public-facing website that many of us in the U.S. use to understand what local air quality trends are and where there may be movement of smoke, even from fires very far away that are impacting local to regional air quality. Blue Sky, on the other hand, in the next slide, is the scientific component that produces that public-facing website and many useful decision tools that fire managers in the US and worldwide use. Over on the left side of this screen, you can just see some of the components that go from fire activity and burned area down at the bottom. And if you squint, if you look very closely, you can see listed a few of those components or subcomponents that go into the fire activity and burned area, as well as leading up from that, the fuel characteristics. So in my team, the Fire and Environmental Research Applications team of the Forest Service, we focus on fuel characterization, consumption, and you can see in the other circles here, those elements are circled: emission factors, emissions allocation, temporal allocation. Those are areas where my team, the FERA team, and also our sibling team, the Air Fire team, we focus and produce individual standalone products such as Consume, FCCS, if you're familiar with some of those, as well as these larger products. So those are just a couple of examples of important applications. So back to the background, realizing this need that was driven by over a decade ago, the consensus findings from prior studies, as well as the U.S. fire management agencies. There were workshops such as this model improvement workshop in 2013 that identified a need to provide real high quality data. And in 2014, a subsequent workshop, this actually marked my initiation into what would become the FASMEE project. This workshop identified a number of different models and modeling systems. I think This is just a small excerpt. I think the total list exceeds 20 different models and modeling systems, decision support tools. Um, but these were the systems at that time that were identified as high priority for one reason or another that needed to be improved. And if you go into the FASME study plan, you can read the details on why they were selected, what they were used for, and a bit more about each one of these. What arose from that initial set of planning meetings, that initial workshop, was the idea to produce this fire and smoke model evaluation experiment. And there is intention behind each one of those words. Certainly, it wasn't just chosen to produce that awkward acronym, but the objectives were and still are to evaluate current operational fire and smoke modeling systems, advance new models into operational use, and the uniqueness of what people have come to call the FASME concept is collecting a coordinated library of data sets to serve as inputs for training, evaluation, and general model improvements. The idea for the conduct of the study would be first to have a dedicated first analysis and planning phase. That is the phase one here in this diagram. Next, to turn that into a field campaign where we would collect observations over active fires. Then to produce improvements in models and modeling systems with those data. And although this is a conceptually concise diagram, you can imagine there should be very fuzzy boundaries among those different phases as they interact. For example, all of us have thought about what the next better FASME study or the next better fire study might be based on what we've seen in all of these different phases. So during the FASME planning phase, the first few years, we conducted many interviews with modelers, first wanting to know what types of data were used by their models and what data sets would be needed to improve their given models or modeling systems, not just in an iterative fashion, but in a generational fashion. Our interest was to say, if the sky is the limit, if there is a carte blanche, what can you do to leapfrog your model into its next better iteration? So the results of that planning phase were included a detailed study plan, had everything from measurement specifications to a budget, ideas and plans for discipline teams, and even down to logistics considerations. I'll share just a tiny aspect of those with you in the interest of time. So again, this is a familiar part of a familiar table in the study plan where initially we chose models to serve. And I say we because, again, at this point, I was involved as a technical specialist in FASME. My own personal history with this project did start over a decade ago and began assisting with those interviews. Later, I would become a part of the measurement teams, making some of these measurements, and eventually I would take a job with the Forest Service 5 years ago and inherit the project as principal investigator. So I have been able to watch this project grow and evolve. So the next phase of the project involved this very messy spreadsheet, and you should simply observe this as a working planning document and realize that the idea behind this type of spreadsheet was for us to attempt to organize what measurements might be taken, how important they might be, when we might be able to collect them. And you'll notice, for example, in the very middle, that black strip of cells there, over on the right side, describes a couple of notional campaigns, 4 of them actually. What types of measurements might we be able to get during which type of burn that we were exploring the possibility of conducting. So all these factors went in together into many, many complex discussions and even negotiations, which would be the more important data set to get, for example, and when could we do it, how could we do it, and who would be there. Another important aspect of the planning was to choose disciplinary expertise that could become part of an interdisciplinary group of teams. So initially, about 6 different teams were chosen. They included everything from plume and meteorology to smoke emissions, chemistry and transport, all the way to on the ground, fire effects, fuels and consumption, and of course that critical element, modeling, which really, I think, graphically should be at the center. And later on, I'll show a much worse version of this slide in which it does. We then set out to envision what the sampling and measurement collection campaign would look like. So in this graphic, we describe groups, teams of measurement personnel and platforms, including everything from radar and LiDAR trucks on the ground, people with clipboards, all the way up to orbiting and flying assets and towers. This is notional. The next slide shows this in somewhat real-life fashion. Of course, modeling in the plume and meteorology, fuels, fire effects, smoke, fire behavior, and we talk about ground truthing, especially those of us who are in the older generations of remote sensing, and this really involves very much ground work. People on the ground greatly outnumber people that we've had making remote measurements for these campaigns. Another extremely important step was to identify a place where the types of burns that we desired could take place. This was a real challenge because, especially 12 or 13 years ago, the emphasis in the United States was on the Western wildfire crisis. So the management agencies had a strong interest and were pushing us to identify locations where we could get conditions that were as close as possible to an intense wildfire. So we found a location after considerable searching at the Fish Lake National Forest, part of the U.S. Forest Service, in south central Utah. You can see notionally indicated there on the map, and you can also see examples of the plumes from the different prescribed burns, sometimes exceeding 1,000 hectares that they would produce. In the interest of time, I'll just fast forward a bit through this video, which includes some sound, but I'll show you a little bit of an example of the types of the types of fire that you can see at these locations. Just note the very heavy fuels. Note the conifer fuels. Note the heavy fuels on the ground, and also note things like the flying embers. And note the winds. Again, I'll attempt here to fast forward a bit. There are a few examples of this video posted online. I do recommend this as a resource, especially for introductory fire science classes or graduate studies as well. You can hear the metal creaking in the tripod that this camera was mounted on. And I'd like to thank my retired colleague, Brett Butler, for the vision and leadership to get this imagery, which is pretty rare. In 2019, we were able to get UAS over these active burns through partnership with EPA, DRI, University of Idaho. We were able to contribute to emission factors research. University of Idaho made some brand new discoveries, which I would really call frontier pushing or boundary expanding discoveries. That would merit its own webinar. Many of these topics might. But I'd encourage you to look in some of the FASMEE resources for some of the outputs. I just don't have time to describe all of those. There have been some operational advancements. For example, as a result of the UAS work, we were able to describe and estimate the firefighter emissions exposure avoided by directing crews to mop up hot spots and save time, for example. This is commonplace now, but 5 or 6 years ago, it was just a relatively new area. So in this next slide, this is the terrible slide that I was talking about. But what I want to emphasize here is that post-COVID in the 2021 till now and future era, under my leadership, I've chosen to re-emphasize the relationships among these disciplines, how they can interact and truly be interdisciplinary. Also, as an important aspect of my work and interests, I wanted to emphasize some of what I called cross-cutting themes. These are fairly obvious if you think about the opportunities evident in a study like FASMEE, but the opportunity to enhance diversity in fire research, to provide cross-training, and the opportunity to collect data sets that are relevant to fire-climate interaction research. I really think that projects like FASMEE are an important training ground for the future of fire research because of all the connections that the project embodies and the types of exposure that can benefit people who are coming into the earlier phases of their careers, as well as later phases too. In 2022, a very important partnership arose through the collaboration with the then new NASA FireSense program. FireSense made plans to deploy pre-fire, active fire, and post-fire sensors over the burns that we were planning and became a part of the planning group. Included in the NASA collaboration over on the right-hand side at the Langley Airborne Science Data for Atmospheric Composition hosting site at Langley, NASA created a data hosting site for the FASMEE data. This was kind of a data aggregator for the initial raw data sets. During the October 2023 campaign, this is for those of you in the Northern Hemisphere, this is the fall 2023 campaign. We had over 50 on-site research participants. We had multiple aircraft, including crewed and uncrewed aircraft flying from both agency and NGO. That includes university, private sector. I mentioned the data site. And something that was really important to me personally was that the small, relatively rural town that hosted us typically does not see a lot of interaction with the scientific research community. Thanks to our friends at NASA, we organized a field day so that kids from the local schools could actually go inside a NASA airplane, meet NASA researchers. This is something that, again, speaking personally, this is the type of thing that inspired me to become a scientist when I was a child in a small rural town. And I hope that we can keep that inspiration going into the future. So this was, I think, a major achievement by NASA, and really wanted to express my continued thanks to them for organizing that event. This is maybe one of the harder slides, the harder topics rather to cover. What is the future of FASMEE? From 2021 to 2024, we enjoyed some relatively significant support from the research and development branch of the Forest Service. Funding for that branch, however, has been unstable for more than the last couple of years. And in the 2020s, there's been a renewed emphasis on, I use the phrase or the word typical with some quotations around it, but prescribed fire tends to be characterized by lower intensity, smaller flame heights, not quite as much extreme wildfire behavior. And there's been an interest in moving FASMEE in the direction of collecting measurements to support prescribed burning. Also, it's important to note that many of the model improvements that we've been after would benefit more from fire in simpler terrain, lower topographic relief, and in many cases, less intense flame heights, less energy, for example. There's been a need for reduced uncertainty related to smoldering and organic soils for so many reasons. Local public health, regional air quality, local safety impacts, and global climate are just a few of the factors that you all know well. So we've shifted FASME to include some additional sites that are lower topographic relief, organic soils, and I forecast that our next campaigns will include organic soil ecosystems, both within and hopefully outside the U.S. But it's difficult to forecast what our opportunities might be. There's no irony lost on me that I'm making these predictions in the midst of the U.S. government being shut down. So it is quite reasonable to me to foresee that the future of FASME may be some future field campaign that takes lessons from FASME. So with that, I'd like to get into some of the lessons that we've learned over the last decade that I share with you in very brief form in hopes that if you are involved in a successor project or a project that learns anything from the last decade of this project, you'll be able to benefit by avoiding some of the missteps and maybe by capitalizing on some of the successes that this project has had. So I'll read through these, or I should say summarize through these relatively quickly in hopes of having some time at the end for discussion and questions, as well as, I hope, fostering future discussions. So the first lesson is that this project required far more help and coordination than I could have imagined, that I think that anyone could have imagined. And by 2023, I was pointing out that we had over 100 participants among at least 6, probably 7 agencies, and over a dozen, gosh, well over a dozen, I think more like 16 university and NGO cooperators in at least 20 states and 3 total countries. The buy-in from all of these groups has been very important, but it's also critical to have a recognition of a central leadership because all of us who've been involved in FASME can point out the shifts and evolutions in agency goals and organization goals. And it's hard enough to manage a project when it is led by one person or a group from one organization that evolves. Much more difficult when there are multiple organizations with their own meandering paths. Another thing that is very difficult and must be considered from the very beginning is data management and data governance. I would say, given my own experiences and the experiences of this project over the last few years, that having a data management plan and backups to it is really important and critical to the project's success. It's also very important to consider multiple scales of implementation. What do I mean by that? You have to be able to envision success even if the grand scale of your objectives can't be met because of, for example, resource limitations or some other factor. What I mean specifically is when the originators of FASME contacted all of the participants and said, let's imagine that the sky is the limit. What does carte blanche type of study look like? We envisioned a budget that we initially had well received by the potential funding agencies. But those funding agencies ultimately, over the course of the forthcoming several years, they were only able to commit to about 10% of that original budget. And if we had been able to scale our expectations, then we could have said, we can't achieve 100% success with only 10% of the resources. That's caused some challenges for us in making prioritizations. If we laid that out from the beginning, it would have been much easier. I mentioned the importance of a logistics team. I can't overemphasize the importance of the fact that conducting live fire science safely requires these incident trained teams. If we were in a physical room and I asked those of us who conduct fire science research, but haven't spent much time around a fire line before to raise our hands. There would be many important, influential researchers who don't regularly spend time around fire. It's important to create a safe spot for that kind of participation. New entry, new technology tools, new participants, all of the forthcoming years in your fire study will see all sorts of new advancements. And if you are able to envision a way to incorporate those, your impact can be so much greater. We've fortunately been able to work in some new people, new ideas, new technology, such as, for example, these slides that indicate AI models, new soil moisture methods such as the miniaturization of passive microwave sensors. I'll give an example of Professor Muhammad Alipour at University of Illinois, who's pictured on the right side of the picture, lower right. Uh, with all of his expertise in wildland fire science, I believe I've captured his first experience putting together a helmet strap for his PPE. So this is what I mean by having that kind of ability to incorporate fire science researchers across the spectrum, cross-training. Having Professor Alipour and his students come out of the engineering lab and onto the landscape, and vice versa, having some fire practitioners understand how data are collected is extremely valuable. Likewise, working across organizations is extremely important. And as you do so, experiencing or even forecasting how differences in pace and culture could affect the fire study. Just one example of that I think really emphasize is NASA is very good at operationally putting large aircraft quickly over wildland fires. My agency, the U.S. Forest Service, isn't always as fast, as rapid, as efficient as NASA can be at very large aircraft. In a few minutes, I'll show a picture of the NASA U-2. However, at the opposite end of the size spectrum, putting uncrewed aircraft systems over wildland fires, even wildfires, is a day-to-day thing for the U.S. Forest Service. This is not something that NASA has grown up to have as one of its regular activities. So meeting those realities and trying to mitigate them has been an unexpected challenge, but one that I hope future successor projects will be able to envision. But partnerships are necessary. So among those partnerships and their goals, I want to emphasize future capacity. Having many of I'll again say the more established, older, later career generation involved to pass along what they know to the future leaders of the wildland fire sciences, to remote sensing, is extremely important. And I'll add a personal observation to that. A decade ago, when I first got involved in this FASMEE project, I was one of those up and coming researchers. And now here I sit as the principal investigator for this project. I personally feel like the past decade, there sure have been some long days, but the past decade has passed incredibly short. And I feel like my own window of opportunity is quite limited to be able to participate in multiple projects of this scale. I think anyone who does would agree, because you don't get very many opportunities in a career to be involved in one of these large, long campaigns. So taking maximum advantage to put new participants in the campaigns so that they can become the leaders of the next ones is something that I think is extremely important. Along the topic of time, there is a very long runway between planning and implementation. And if you think about your own favorite funding source in the United States, it might be an agency like NASA or National Science Foundation, maybe even my own agency. But a 3 or a 4 or 5 year funding timeline is still quite short compared to the amount of time that it takes to envision and properly plan and execute a project of this scale. And so having the ability to span multiple funding timelines, however you do it, is something that's important to the success of a larger project. Um, in considering several of these lessons, I realized it's important to point out that this approach is not for everyone. So we've encountered many people who are from, you might call them more risk-averse populations. These could be graduate students who can't wait around several years to complete their degree, but still having exposure to the wild and fire sciences and an interdisciplinary project is very important. Likewise, people who are on the tenure track may not be able to wait 4, 5, or 6 years from data collection through publication. And so it's important to be sensitive to their needs, even if those needs include not participating or participating only in limited fashion. But we like to include as many people as it is relevant to include. And so there is a balance between that inclusion and also, I say side quests here, but another term you might include is scope creep. There are other thoughts on an expanded discussion of this, but in the interest of time, I've just got a couple more slides to share. One of those concerns an event that happened just this summer, and this, I suppose the lessons learned is to don't be fixated and too anxious about the unexpected, but keep in mind that it can happen. Those black swan events do occur. So one of the things that we never asked ourselves in planning the FASMEE project was, what would happen if we accidentally had a wildfire that ended up burning up all the remaining study sites? And on the morning of July 14th, I believe it was, I came to work and I learned of a small fire that would eventually, over the course of about the next 6 weeks, it would do that. The Monroe Canyon fire, which was just recently a month or so declared out, burned over 30,000 hectares, about 73,000 acres. I've put a small version of the fire progression map over on the lower left, and included within those various chloropleths are pretty much all of the future study sites that we had envisioned. So if you're sitting there in the audience shaking your head with some form of sympathy or irony, thank you. However, we did take advantage of a number of built-in features. We had these incredible collaborations with NASA. You can see this photo from July 30th when the U-2 made a couple of overpasses during fire. I'd really like to express a lot of thanks to NASA and USGS for that effort. I'd also like to express appreciation for the UAVSAR group, who just within a couple of days of the fire outbreak was able to collect during fire UAVSAR data. So we'll have a pre, during, and post-fire UAVSAR data set, we think. So that created one opportunity from the remote sensing standpoint, while the pre-fire measurements that had been taken at some of these sites allowed us to leverage this into a very highly studied wildfire that has what a lot of wildfires don't, which is pre-fire data. So that still creates a valuable opportunity. As well as some questions about what our future involvement at these Utah sites will be. So as a final note, final insight or lessons learned point here, it's easy to get wrapped up in your own project and realize that yours are not the first footprints on this landscape. Uh, in acknowledging all of the participants in FASMEE, I'd be remiss if I did not acknowledge all of the knowledge that we built on, all of the predecessors and predecessor studies. And it's my hope through resources like the knowledge that we've learned, our network of collaborators, and resources like the Global Fire Community, that we can ensure that these lessons get used to our mutual benefit in whatever will take place after FASMEE does. So thank you once again. I hope I've left a few minutes for some discussion. What I'd like to do, I think, in the interest of organization, is minimize my own screen, and hopefully I will be able to participate in the question answer. So I'll turn the mic back over to the facilitators, and thank you once again.
Thank you, Adam. That was really a very nice talk, and I think you took quite a bit of time on some important lessons that are, I think, very, very important for people who are working in similar domains, as well as for those who are probably going to link it to more regional or local problems around the world. And I think it had a lot of food for thought. In many aspects, like from data collection and the trouble associated with that, and also responding in a timely manner to whenever such an event occurs, and coordinating all the efforts across the multi-agencies that who would be involved at the same time, depending upon their mandate. So for me, at least, I learned quite a few things from your slides and your description about it. So for the audience, I would like to share it once again that this webinar today is co-organized by MERS and React, and if you would like to join the mailing lists, I have posted a link in the chat box. Please follow that and sign up. We'll be happy to have you on board. And I think we already have some questions from the audience. We have one participant asking, how can young innovators contribute to FASMEE's vision or ongoing projects?
What a wonderful question. As I process that for just a moment before I answer, I veered away from the final slide before I pointed out that there are a couple of websites where, if you're curious about what outputs have come from the study, I listed two links in the comments. And if the hosts would like to share those, there are just two websites. One is a larger or longer URL, and one is FASMEE.net, where we try to keep a periodically updated bibliography of some of the research outputs. Okay, now to the question of I am a student or early career aspirant, and I'd like to participate in studies like this. When I have received inquiries like that myself, I've made it a priority to try and include graduate student research, generally as one of those components that doesn't have to feed the larger goal of producing data to evaluate models. For me, graduate education has become kind of its own objective. And so I've encouraged both close and more distant collaborators as co-PIs to include their students. So for example, if I'm a graduate student and Professor X or Y is my advisor, then with them, I would want to contact someone like me or one of the other team leaders and say, hey, I'm interested in vegetation dynamics post-fire, or soil erosion, remote sensing of fire energy, any of these different disciplines. And I'd like to explore either conducting some work and some observations, or I'd like to find a way to use the data that are coming out that are already collected. So be bold, I think, is the short answer. Be bold, and in concert with your advisor, if you're a student, or maybe other collaborators, just reach out, and we'll try to accommodate you. I say that on behalf of FASMEE, but for other studies, be attentive, especially at the conferences. Watch out for those groups of people that you might think of as well-connected researchers. If they're standing around in a huddle, they might be planning something. You might want to be a part of it someday. Barge in there and see what they're up to.
Right. Do we have any further questions? Please feel free to use the Q&A option and post your questions. In the meantime, I also have a couple of questions, and I was just thinking out of curiosity that Although most of what you have presented is about the wildland fire issues and the FASMEE project that you have been leading as a PI and contributing to over time. You would have heard about the persistent smog and uh, and the bad air quality over South Asian region, spanning from all the way from let's say Afghanistan area all the way towards north of India and so on. And the smoke and the bad air quality is mainly, or one of the reasons for that is the burning of crop residue. I mean, that's not a violent stuff, but it's still like burning and the smoke spreading all around. Do you think that the findings or the models developed under this FASME framework, do you think they are applicable in some sense to that?
What a great question. I think so. And I think there's great opportunity to learn a bit, or to perhaps a better way of expressing my thought is I think there's an opportunity to conduct research at similar scales on this incredibly important issue of regional haze associated with biomass burning. I'll share very briefly. One of my own major learning opportunities came when I went from a PhD in ecology into an atmospheric sciences division at the Desert Research Institute, and I learned so much about the transport and evolution of emissions and atmospheric processing from biomass burning of peatlands in Southeast Asia, which is a bit more closely related to my research, but as well as crop residues and biomass burning further to the west throughout the Indian Asian subcontinent. Um, these are perhaps equally, maybe even more important than global wildland fire smoke because of the millions, billions of people who are exposed to it. So there have been, I would say, some useful studies on atmospheric aging relevant to the FASME project that I think could be ported over to some other biomass burning studies. I would be delighted to see that happen.
Yeah, correct. Make yeah. I have a couple of other questions in the meantime, and some of the audience, perhaps here now live or maybe later on the GRSS channels, they might also like to know the aspects, let's say, related to the technological KPIs that this project involved. For example, in terms of the Earth observation, do you think LiDAR made more sense to you, or satellite imaging with optical imagery, detecting fire events, or things like that? Like as a layman approach, what do you think hit the most, and where people need to focus on in terms of research, further experimentation?
Um, Uh, wow, that's a really good one, and I think I'm thinking now across some time spans. And during the course of this 10 years, we went from initially saying, "Oh, we'd better rely on orbital platforms and large crewed aircraft, such as NASA flies," and wondering if maybe drones, UAVs, wouldn't be very relevant. To now, in the 2023 campaign, we saw, oh, excuse me, 2020 campaign was the first time we saw greater reliability of our unmanned than our manned fleets. And so temporally, we've seen this revolution in the small, low-cost, flexible drone platforms and the miniaturization, the continued miniaturization of these sensors. So from the EO standpoint, electro-optical, I think that the combination of the small payload LiDAR aboard the drones and combining that with a larger footprint available through larger airborne platforms has been tremendously useful for fuels consumption. Um, at the same time, I've been extremely inspired by some of the developments in the microwave and radar sensing as they could be applied to estimating fire severity and future environmental effects by measuring things like soil moisture. That's a very important determinant of post-fire vegetation and ecosystem recovery and processes. We are still seeing developments on that front, and I have yet to be fully satisfied with the maturation of that technology. So I guess it depends a little bit on the field, but I would say overall, from the remote sensing standpoint, LiDAR, I think, has really come into its own as a major tool that is mature enough for management these days, whereas passive microwave and radar are flourishing in the development phase. And I think that maybe toward the end of my career, I hope that I can see those translated into management ready tools. Those are just two. But it's so fascinating to be able to see others with new technologies that I can hardly imagine, bring those and apply them to these studies. So keeping a place open for something that isn't even envisioned yet is a great idea too.
Yeah, yeah. That you also use a very nice word, management ready, because that's the sort of thing in our technical committees we discuss, or in the sense that technology, what is already out there in terms of state-of-the-art research, how do we translate that into actionable things? And I think it's quite impressive that you feel that this particular electro-optical or LiDAR has been very well suited for these sort of large scale wildland fire management. I think we have a couple of questions, so I would switch to that. So we have a question. I would like to ask if FASMEE allows independent or student AI researchers to access its data sets for academic or experimental research purposes.
Yes, we will, and that is one of the ultimate objectives. If you hear me promoting this notion from even a few years ago, one of the things I have always said is we want to serve the models and we maybe call them client modeling systems that we identified early on, but it became apparent as we were getting into the project that there would be users of these data that we had not met yet. And this question obviously comes from somebody that I haven't met yet. We would like to serve your needs because this is research in the public interest. So when we finally get around to having a well-curated, high-quality data set, and that'll probably be one of the upcoming questions, when will that happen? But when we do that, it is my hope that people who I may never meet will benefit from this and will use it. If it's high enough quality and they're able to do that, then I will have achieved some success in this project. Now, to the closely related question of when will this happen, we have been working on aggregating kind of rough sets of the data that the researchers produced, placing that on our NASA site. Those are not quite ready for public consumption, I would say. We've been going through the longer process of QA, QC, and trying to aggregate and serve those data up on the U.S. Forest Service side. That project was well underway right before October 1st when we had the shutdown. So I'm a little bit hesitant to forecast when it will be complete, but I'm hopeful that in the next year or so we might see some data sets published. You can already, however, you can already access a few data sets that have been collected. If you look on these websites, there will be lists toward the end of these of the phase 2 final report where a few of the researchers have already published their data. So hopefully that could be a resource that might be useful to some out there.
Right. So we are getting a little bit over time, but we will have one last question. What are the key research areas, in your opinion, which remote sensing can help play a major role in today's fire studies?
Okay, let me first, at the expense of just a moment here, let me first tell you what I think may not be. You know, we've all seen a race for immediate detection of fires. a generation ago to a few years ago, we had fire detection increasing in rapidity up to just a few moments post ignition. Now I think especially with the classified military assets. I will disclose that I do not have any kind of security clearance, so this is totally a guess, but I think we can guess that the military spy satellites are probably quite good at seeing a very small fire very quickly after ignition. What would we do with that information, though? So the question I ask is, what if you had some magical remote sensing ability that was actually able to predict a fire, or excuse me, to detect a fire? I've shot myself in the foot a bit. But what if you could detect a fire 1 second before it started, 1 minute before? So where I'm going with this is the other side of the timeline. I think that if we can take some combination of fire observation data, fire behavior data, fuels data, and I think this is really where AI will make great achievements in the future. If we can begin to predict where fires may occur, that's one area, and that's rather technical. So fire prediction is one, but I will lay another topic right next to it, and I will say that we've seen that the more we put out fires, the less we're able to put out fires. So as we suppress fires, we see buildup of fuels, and there's kind of an arms race between fire detection technology and fire suppression technology. So that in the United States anyway, we've seen that lesson before. And so then I think a very important question is, once you have some idea of where the fire will be, what do you do with that? So I think there needs to be an evaluation of fire policy as well. Where is it very important, critically important to immediately suppress a fire? And where are places where you can have some kind of fuel mitigation prior to the fires occurring? Or are there places where you're going to suppress fires to the point where any fire that happens becomes devastating? I don't have answers there. Unfortunately, we're so far beyond time that I shouldn't go in that direction anyway. But that's a very thought-provoking question.
Thank you, Adam. Thank you for the wonderful discussion, as well as all the content that you shared with us today. I'm really grateful to you on behalf of both of React TC as well as the MIRS TC, and hope to see you at some conference with more interesting results and findings. And
Thank
I
you, sir.
would also like to thank all the participants for attending today's webinar. Hope you would join us again for the next webinars. Thank you very much. Have a good day.
Thank you so much.